Hi everyone, so let's continue solving problems together. Yeah, so let's see just for completeness sake, I'll go through the following problem. If P is greater than 5 and it is prime, and P is divided by 10, show that the remainder is 1, 3, 7, or 9. So if we apply the division algorithm to P, then you get that P is a multiple of K plus a remainder, where that remainder is between 0 and strictly less than 10. So here, since P is prime, we cannot have the remainder of 2, as that would give us an even number. We cannot have also the remainder of 4. We cannot have the remainder of 6. We cannot have the remainder of 8. And we cannot have a remainder of 0, as it's all of those things would allow us to have that the P is even, and we are given that P is bigger than 5 and the only even prime is 2. So that's the main reason. So I don't need to go over the details here. It's just like you can, like the details, you could, as an exercise, you could write it out for yourself. So let's continue solving problems then. So let's see question 9. So let P be an integer. Other than 0 plus or minus 1. Prove that P is prime if and only if it has the following property. Whenever R and S are integers, such that P is equal to R times S, then R is equal to plus or minus 1, or S is equal to plus or minus 1. So let's solve this problem. So assume P is prime. So if P is prime, then its only factors are plus minus 1 or plus minus itself. So you could do it in multiple ways. You could do it directly. You could also invoke theorem 1.5. So let me do this directly, and I will. You can show using theorem 1.5, or I'll do both ways. Why not? So let me use theorem 1.5 first. So assume that P is equal to R and S. So therefore P divides RS. So which means as P is prime, we can invoke theorem 1.5. So therefore P divides R or P divides S, and if P divides R, you can replace R by a multiple of P. So therefore P is equal to P times K times S, which means that K times S is equal to 1. So in absolute value, K, or I guess S, is less than 1. So that means that S is plus or minus 1. And by a similar argument, if P divides S, then R is equal to plus or minus 1. Could also prove it by the definition of what a prime is. So if P is R times S, the only factors of primes are plus minus 1 plus minus P. So the choices for R, if R is equal to plus minus P, then this restricts the choice for S being plus minus 1. And similarly, if S is plus or minus P, then the R would be plus or minus 1, and we are done. So let's go in the opposite direction. In the opposite direction, assume P so again you can invoke theorem 1.5 in the other direction, but I'll do it directly. So assume that P has a property whenever it is multiple of two integers, then one of the integers is plus minus 1, or the other integer is plus or minus 1. Okay, so assume let let R be a factor of P, and then we want to show it's plus minus 1 or plus or minus P. So P is equal to R times S, as R is a factor for some S belonging to Z. So that means we have that R is equal to plus or minus 1, or S is equal to plus or minus P, plus or minus 1. So if R is equal to plus or minus 1, we are done. So assume that S is equal to plus or minus 1, then R is plus or minus P, and we are done. So all the factors that we found out, all the factors are either plus minus 1 or plus or minus P. So P must be prime. Alright, I'll end the video here and we'll continue next time. See you guys.